ever watched a sci-fi movie before, you have probably heard of quantum entanglement by now. But you might not know what it means.
Because things at the quantum level are so complicated, it's easier to understand them by using analogies.
You pack two balls into separate boxes. If one of the balls plays a sound, the other goes quiet. One of them is shipped to Canada and the other to Japan. Although they are physically far away, they're still connected to each other, what we call entangled.
The balls in the analogy represent a particle. In quantum physics, a particle can be in a superposition. This means that it can be in multiple states at the same time.
Let's say both balls were fluctuating between multiple colors before you open the boxes. Now, instead of sound, each ball will affect each other's color. You observe your ball in Japan and it's red. And although you haven't seen the particle in Canada, you know that it's also red because of the entanglement.
This is also how quantum computers work. Instead of using normal binary, like a classical computer, they can be at both states at the same time, both true and false. With this superposition and entanglement to other qubits, quantum computers can process data so much faster and much more data compared to a classical computer with classical bits. This means the behavior of one particle will change the behavior of another. This can happen across the entire universe. This does not break relativity because it moves slower than the speed of light. And you can think of the quantum entanglement as a single object.
The only thing necessary for entanglement to occur is that the particles must have interacted in the past. This also means the distance they have traveled away from each other since they last interacted has to do with their speed and how much time has passed.
Think about it, it's like a subatomic way for particles to text each other.